When you're learning to graph quadratic equations, sometimes it's hard to know where to start. The good thing is that the function that you're given has a lot of information in it that you don't even have to work that hard for. The first thing we notice is that we have the equation in standard form, y equals ax squared plus bx plus c, where a, b, and c are different coefficients. Now, what can we find out from the very first coefficient? Your a actually tells you probably the most. First of all, a tells you whether your graph opens up or opens down. If a is positive, then you are happy because your graph opens up like a happy face. But if a is negative, then we're kind of sad. So our graph opens down like a sad face. So that's what you need to remember. When you're positive, you have a happy face. When you're negative, you have a sad face. That's going to help you remember whether it opens up or down. Your a can also tell you how wide or narrow your function is going to be. If the absolute value of a is less than 1, your function is going to be really wide. And if your absolute value of a is greater than 1, then you're going to have a function that's more narrow. So all of that, whether it opens up or down, and how wide or narrow the function is going to be, you can find by just looking at a. Now let's see what we can find when we look at c. C is really beautiful for us because all that is your y-intercept just written out for you. So our y-intercept is going to be in the form of 0, c. That's the ordered pair that talks about our y-intercept. So before you even mess with this function, you already have a point that you can graph so that you know where that is on your parabola. That's a great starting point. Now you may be wondering what it is that we can do with this b. And luckily there is something, but it's not quite as straightforward as your a and c. Your b helps you find your axis of symmetry. Your axis of symmetry is the equation x equals negative b all over 2a. So for the b, there's nothing it can tell you on its own, but when you combine it with your knowledge of a, you can find the axis of symmetry, x. Another great thing about the axis of symmetry is that your vertex actually lies on the axis of symmetry every time. So whatever your value is that you got for the x here, if you plug that in to find y, you will have your x-coordinate and your y-coordinate of the vertex, and you can start graphing. Now, breaking all that down might be a little bit overwhelming, but I promise it's going to make it a lot easier when we get to our example. So let's go ahead and look at one. We have y equals x squared minus 2x minus 1. The first thing we need to do before we even start is figure out what our a, b, and c are. Here, we have nothing in front of our x squared. So does that mean our a is 0? No, it doesn't. And I know you're going to want to say that, but it's not true. We know that when there's nothing in front of the x squared, really what it's saying is 1x squared. That means that our a, in this case, is just 1. Now, what is in front of our x? In this case, it's a minus 2. So our b is going to be negative 2. Now, one last one. We have our c at the end, which is minus 1, so that means our c is negative 1. Now how fantastic is that we already have our a, b, and c. Now let's think about the first thing that we do that we know for sure. We know for sure that our y-intercept is our c. So that means we know for sure that one point on our graph the y-intercept is 0, comma, c, which in this case is -1. So 0, comma, -1. So, just because we can, let's go ahead and plot that point on our graph because we know for sure that that is a point on this function. So, we go to 0. X is 0, y is -1. Our y-intercept is right here at -1. So we have 1 point on our graph to work with. Now, let's see what we should do next. Our second step is to find the axis of symmetry. Now, the first thing we need to do is remember our equation. Does anyone remember what it was? That is so right. X equals -b over 2a. We already know what our b is, and we already know what a is. So that means that we know that we can plug in and find our axis of symmetry. So in this case, we have x equals -b, which in our case is -2, which makes it just a regular 2, all over 2 times a. Our a is 1, so 2 times a is just 2. So our axis of symmetry is x equals 1. That is great news. Now we know when we plot x equals 1, everything on the left side of that is going to be a reflection of the right side and vice versa. So let's go ahead and draw that axis of symmetry. We're going to come over here to x equals 1, and we're just going to go straight up and down a dotted line. Now, if we wanted to be smart, we would notice that there is already a point on one side of x equals 1, so we can put that same point on the other side of x equals 1. So, at y equals -1, we have a point when x is 0. That is 1 away from our axis, so we go 1 away in the opposite direction, and we have another point at 2, -1. That is on our equation. Now that's really nice because we already have 2 points, but we really need to plot a few more. The easiest one, the most important one, is to find our vertex. To find our vertex, we have to have y when x equals 1 because we know that our vertex is on the axis of symmetry. So, the first thing we need to do is we need to make a plot for points. So we have x and y. Our vertex is going to be the very middle of our parabola, so that's going to be the middle point we find. Let's go for 5 points. So our middle point is when x equals 1. And what are some points around 1? We're going to go 2 before 1 and 2 after 1. So the after ones will be when x is 2 and when x is 3, and the before ones will be when x is 0 and x is -1. Alright, so now we need to plug those into our equation up here for x and see what we find for y. I'm going to go ahead and do this on my own. You can do it on your own as well. We plug in when x is -1, we get y is 2. When x is 0, we get y is -1. We already knew that one because we know the y-intercept. Then we have when x is 1, this is our vertex. We're going to have y is -2. And when x is 2, we're going to have y is -1. And when x is 3, we're going to have y is 2. So our vertex, one of the most important points, is right here at 1, -2. So let's go ahead and plot that point. Go open, go down 2. There is our vertex. Now the rest of them. When x is -1, we go up 2 in the y direction. When x is 0, we have y is -1. We already have that one. We just did our vertex. When x is 2, we have y is -1, which we also have. And the last one, when x is 3, y is 2. So we go 1, 2, 3, and up 2. Now all we have to do is connect these points. And we have a parabola. And it is indeed a happy face parabola, which means our a should have been positive. And it is